Let's continue our study of methods and references by tracing parameter passing. What we're going to do here is an analysis of code. Really, memory diagrams are the best tool for analyzing errors in code. This is especially true if the errors are in memory allocation or in parameter passing. So we're going to re-examine some previously written code with a memory diagram and then take a look at another option and see if we can actually see what's going wrong. So here's the method we did. This is split with an oversize array. We wrote this code just a while back. So we've got our split method. We're using a scanner to divide a string up based on white space. We've got an integer index and we step through it one position at a time, keeping track of the number of strings and storing them in the string array called result. Remember, result has to be allocated before the method starts. And then at the end, we return the index. That is the number of elements that are actually live. Now, in order to analyze the code, we're going to need to call it. So here's a main program that does just that. We have a final int size equals 5. Notice that's a constant, so it's in all caps. Then we have string input. We have our sample string input that we were going to use. Then we have a string array for the results, and that's allocated to the size. So this is an oversized array in this case. Then we call the split method. Now, split method is going to return size. Notice in small letters instead of capital letters. And it's going to take the input, and it's also going to take the array. The only thing that's done after that is a for loop that prints out the data. That can be a useful thing to have for debugging. So let's trace this now and see what happens. In our main stack frame, we've got our constant 5, and we've got our input, which is a string with A, B, C, D, E, F, G, H, I in it. Then we have our array. Now, when it's allocated, we allocate, remember, the positions on the heap. And then we call our method. Now, the integer size doesn't have anything in it until we return from the method. So while it's there in memory, we're not actually going to use it. Here's what happens when we call the method. Now, the main stack frame isn't going to be changed. In fact, the main stack frame isn't even active while this is being done. What is active is the split stack frame, because that's the method that's being worked on right now. So you'll notice we have places for source and result. Those are the parameter names. And also a place for index. Index is a local variable in the method. Now, I'm ignoring the scanner here because we really don't understand how a scanner works. Hope that's okay with you. So, right now, result and input are pointing to the string and the array that were previously allocated on the last slide. Now we need to pass our parameters. Result in the split stack frame gets the value of result in the main stack frame. And source gets the value of input. So now the string, A, B, C, D, E, F, G, H, I, has two different things pointing to it. It has the input in the main stack frame and the source in the split stack frame. Similarly, that 5-element array is referenced both in the main stack frame and the split stack frame. Now we're going to step through our loop. So first, the index is 0. Now, input has index is still true because our scanner still has data in it, and we're certainly still less than result.length, which is 5. So we put the first string, which is ABC, into the array, and we update the index to 1. Similarly, we'll put the second string in the second trip through the for loop, and the third string in the third trip through the for loop. The index value will end up as 3, because 3 there is going to be the value when input.hasNext fails. And now we return index. Now at this point, the value in index is 3. It's very important for us to notice what's going to happen. Split stack frame is going to disappear when this method is over. And anything that's pointed to by only data in split stack frame is going to disappear too. Now, because result and input point to the string and to the array, those things are going to be kept. Now we return to the main method. Now the only thing that's going to be changed here is the 3 that's returned by the split method is going to be put into size. Then we would print things out. I'm not going to show the printout in this case. So what you can see here is the result ends up having 3 strings in it, A, B, C, D, E, F, G, H, I. Each one pointed to a reference. It's oversized because notice out here we have 2 elements in the array that haven't been used, and the variable size contains 3. Everything's working beautifully here. Now let's change the code. Now the reason I picked this particular change is it's one that I've seen many students make. It's a very difficult problem to debug. So let's take a look and see what happens. What we're going to do is allocate the result array in the split method instead of in the main. Now another common mistake I see is allocating the array both in main and split. That's kind of bad because at that point it can be very confusing to know which array is which. Now we're not going to be able to change the signature of the method. The reason is that returning size is absolutely necessary. So the method is going to have to return an int. So we can't change the signature. So let's see what happens now. So here's our call method. Notice I've changed this method a little bit. Here, when we declare the reference result, we're not constructing the array. So result now is a null reference. You see this in the code by the slash across result. Everything else is exactly the same. Now let's take a look at what happens inside the split method. Notice the change here is that we've added a constructor for result. So we're passing in this null reference result, and then we're constructing a string. So there's the null reference that gets passed in for result, and source gets input from the main program. Now our scanner input is created from source, same as before, and now we construct our result array. So there is our 5-element array. Now at this point the size is 0. We don't have any elements actually in the array. So we're now going to step through one at a time, adding strings in. Just as we did before, they'll be added in one at a time, and this will result. Now we're getting ready to return index. Well, index is 3, which is the correct value, and so everything's going to be right. Except let's take a closer look. Notice that the 5-element array is pointed to only by result in the split stack frame. When the split method ends, the split stack frame goes away, and so that 5-element array and those 3 strings it points to, the A, B, C, D, E, F, G, H, I, all of those are going to go away too. So the only thing that's going to be live on the heap is this one string with A, B, C, D, E, F, G, H, I. That's obviously a very serious problem. The other way to analyze this by looking at it, take a look at the main stack frame here. There are 2 things that need to be set. Result really needs to get the value of this string, the reference to it, and it can't. Size, on the other hand, needs to get 3, which it can because we have an integer return type. So really, we've got a problem here. So when we go back to the main method, 3 gets put in size, and that's all that remains on the heap. Notice our result array is null, just as it was when we started. We haven't done anything. Very disappointing result. So here are the parameter passing rules. Arrays that are allocated in a method, like split, have to be returned to be used in the calling method, like main. Alterations that are made to a parameter in a method like split are seen by the calling method, which is main again, as long as the array is not reconstructed. So this construction is the big issue. Now these same rules apply for objects, and that's not really an accident. Because arrays are stored by reference just like objects are, these things work the same way. And if you can understand that, you're going to have a much easier time to understand parameter passing in Java. Keep programming.